Hey everybody, Daniel here from Basement Tech. Daniel from Basement Tech, you say? I haven't heard from him in a while. And that is true, I have to admit, and I have to apologize for that. But things have been just really busy, both in my personal life and down here in the basement makerspace. So many things going on. I'm going to talk about one in particular today, but give you a little teaser for some of the others. I bought a Chevy Bolt, as in Bravo, all electric. I'll talk about that probably in a video. I helped liquidate a friend's estate who sadly died recently. A lot to talk about there too as well. Moved some more equipment out of the basement down to the Zim Knives shop. Remodeled one of our bathrooms. And mostly though, I've been working on the project I'm going to talk about here on this video. That's the new controller for the CNC router, the wood cutting machine. You might remember I did a video on that, a brief one, and I talked about the controller and I talked about the motor controller itself. And I'll talk about that coming up here, but it just failed, so I'm rebuilding in a big way. That's the topic of this video. Well, before I get to the new controller, I wanted to give you this one just for reference. You might remember this from the prior video. You might remember me talking about this Lead Shine MX4660, how much I hate and despise it. I would never recommend using it, and even more so now because it failed for a second time. Really not a fan. I have used integrated, 4-in-1 controllers like the Gecko G540 very successfully on our metal cutting mill, but this one just seems not to be able to hold up to the kind of operation that we're doing with this mill. So I'm going to turn around and be prepared to be a little bit wowed because this one's just way more capable. This is the new one. Those of you who are familiar with these kinds of things will see the components right away that lead me to believe that this is going to be much more robust, and I'm going to go through all of those components and reasons for my choices here coming up shortly, but it's just a lot more capable in general. Over 2x the capacity of the old one, and that just leaves a lot more margin for the abuses that you see in the real world. Okay, let's take a tour. Well, let's start over here where it all begins. I have this 15 amp twist lock for AC power input. This is going to run at 110 volts, for here in the United States. The switch in the middle there, this little toggle is power on, but it only powers on the 12 and 5 volt DC, and this little green light is just a pilot with a fuse there. The big red button I'm pretty excited about. I'll show you on the other side. It actually engages the 48 volts for the motors. And I'll show you on the inside. There's a relay, so if the power drops out, the 48 volts don't come back up until you press this, call it a run button. So on this side, I hope you'll agree, I kind of went to, took a little bit of care in making sure it's, safe and laid out well. A little bit of 120 volt distribution down there. I have this big fan, and the idea is, I'm going to draw air from over here across the power components and then back out this corner up here. I'm also going to allow a little bit of air to come in here to cool that power supply. So there's the relay I talked about. I opted for a mechanical relay, partially because I had it and partially because, I don't think it's a bad idea. Basically that holds the power on to the main 48 volt motor power supply, but when the power comes back on, you have to manually engage that relay. As always, I've used components from my junk box, so if you see some things that kind of look overkill or a little bit over the top, that's probably because I had it in my my junk box. So for example, this is that giant switch. It's pretty big switch for the application. It pulls that relay in over there, and it has a light, and the light is actually feedback from the relay to say that the power has in fact been pulled in, so that's kind of useful. Proceeding down this way, I'm going to talk a little bit about this this power supply in the corner. It's 48 volts, 20 amps, but it's unregulated. In the past, you've seen on my videos that we've used 48 volt switching power supplies, and I just thought that's what everybody did. But as I researched and talked to Gecko and others, they actually recommend using an unregulated power supply so that the regulation of the power supply doesn't get in the way of sort of the back and forth of current from acceleration and deceleration, the so-called back EMF. So this one has pretty big capacitors on it, and I think that's going to help. I may add this big guy that you might remember from the other controller just to help out with those sloshing of electrons. Up here is a 5 and 12 volt switcher. I learned something about them that you may already know, which is some of these, if they don't have any load, they don't regulate. So, you know, this dummy load, these resistors up here, are to provide that that load just so it comes up completely stable, 12.0, 5.0 kind of thing. I'm going to go here next to the controllers. So 48 volts is going to come down this way and through this shunt. The shunt is a little bit just for fun. I had it in the junk box, and I think it would be fun to kind of put a overall stress meter, if you will. In other words, how much total current is coming out of this big honking power supply. In the extreme, I may even put some colored LEDs that indicate the stress of the machine so that it kind of almost looks alive when it's cutting. Up here is 48 volt distribution. I've just begun to wire that. And then kind of the second star of the show, if you believe the big power supply is the first. This is a big difference. I'm going to go up here where they're right side up for you. These are the so-called indestructible Gecko 203B. I'm really excited about these. First of all, they're discrete. That allows me to really spread them out onto these heat sinks, which again came from the junk box. So you might think they're overkill, they're not mismatched, but I think the bottom line is they're going to provide great heat sinking for these much more capable controllers. They take in step in direction and just output the pulses to the motors. They're over twice as capable as what I had previously. They're capable of 80 volts, which is almost, you know, twice as much as I'm running, so good margin there. But back EMF can cause some voltage spikes, so these should be able to handle that. And they're capable of 7 amps, which is about, call it a 50 or 75% margin on current. So I really expect these to do well with that heat sinking, with the active air through that fan. I really expect this to be a good, robust system. One of the things I did salvage from the old one was this. That's the smooth stepper. I really like these. This one happens to be the Ethernet smooth stepper. It takes Ethernet in this side and outputs using these essentially emulated parallel ports to provide the outputs and take inputs from things like the limit switches, etc. I had one of these, actually it was that one, which is the C10 from CNC 4PC. So I just decided to get another one. This is, if I was really clever, I probably could have used one. I have 4 motors. You've been counting controllers and note that there's 5. Planning ahead for a rotational axis, a axis. Remember the Y axis on this particular mill has 2 motors. I'm going to drive those independently with 2 controllers. So I do have either a hot spare, or I'm preparing for that that A axis, that rotary axis, so I can do things like what? Engrave baseball bats, for example. So from a wiring convenience point of view, this one here is going to drive the motor controllers, and this one up here is going to take the inputs and provide outputs through this panel. I'm a little bit proud of this. I machined it down at the Zim Knives shop. Note those are D-shaped holes, which is pretty exciting. So Ethernet at the top. These D-shaped holes are accommodating these, which I intend to use. Can you see those? There it goes. Those are actually mini XLR, and I hope they work out well for the limit switches. If anybody has any comments who have used those, please let me know. And the standard DB9s for motors. This one here is just a convenient way to get Ethernet in through that square hole, which is pretty fun. So that will mount on the flat side over here, so all the wires are going to come in this way. That's going to leave this big area down here, as I said, for incoming air. I'll put some kind of filter material, keep it clean, of course. And over here, this little hole, the same thing. I want most of the air to come from this side and leak across in this direction. That's going to pull some air across this power supply and across these dummy loads, if you will. I don't know if I can show you. Back here, there's a little heat sink to pull heat out. As an engineer, it kills me to have to put components in that actually intentionally heat up. So that's problematic. So there you go. One final thing to talk about is actually this chassis. As many of you probably have too, I priced out, neat boxes, those NEMA enclosures, the heavy duty ones, and they're just obscenely expensive. So I decided to try to make something myself. The base plate is an 1/8 inch 6061 aluminum plate that has served really well to mount things, and that plate is actually backed up by some wood blocks and this piece of plywood, so it's very stiff. The chassis itself is just pop riveted together aluminum angle from the big box store. I think that's going to work out really well as an enclosure, and once you play and get the methodology right, it goes really, really fast to build that up. I'll close in the rest of the sides, put a cover on it of some sort, and I think that's going to work out great. Well, I'm going to leave this video here. It was meant to be kind of a tour, and hopefully the next video I'll be showing on this topic will actually demonstrate a motor or two moving here. Got about half of the wiring done. The rest is the putsy stuff, little tiny wires that go from those breakout boards to the limit switch connectors and up to the step and direction, and the 48-volt power, which I have to wire up. So I'm really, really looking forward to getting this down to the shop and doing some fun projects with this CNC wood cutting router machine. So thanks for listening. If you like this kind of video, and especially if you want to see this thing when it's finally working, please give me the thumbs up, and if you really, really like it, press the subscribe button. Thanks for listening, and I'll talk to you soon. Promise.